So here this is another case, okay, where you can get confused by the kind of common sense or everyday understanding of the meaning of force and what force is in physics, okay? So you could say in everyday language that the 100 Newton force is moving the 20 kilogram mass. And that's not true in physics, okay? Because the 100 Newton force is applied to the 5 kilogram mass. So if the 20 kilogram mass has something, okay, it's because of whatever is touching it. And what is touching it is the floor and the 5 kilogram mass. Okay, floor doesn't really matter.
Not sure what you said there.
Frictionless, okay? So here is, let me just switch back here. I don't know why it shows these things. I'm very annoying. Okay, so here we have this 100 Newton force acting here. And now we're going to have, so if we do if you imagine also, if you have them like this here, and imagine an imaginary surface here, you say, well, here is, this object is touching the environment at the bottom, okay, so it is normal. There is friction, but there is no friction because the metal is frictionless. And then there is the effect of the other mass, okay, and so the other block 4. Okay, so these two forces go to enter in the free body diagram. So here, on this one, you're gonna let's call this one A and this one B. So this is going to be FA on B. Okay, and now I'm not going to put the vertical forces here because I'll cancel out. I'm more interested in motion in the x direction. So, and what else do I need to include here? Well, because of this force, okay, because of Newton's third law, there wouldn't be force here. In fact, I should draw the one here. So this will be FB on A. Okay. So if I do the Newton's second law for this one for A, I say 100 Newton minus FB on A is equal to the mass of A times the acceleration of A. For the second one, I have FA on B is equal to FB times the acceleration of B. So I have two equations. Okay? And what do I know about these two forces? B on A and A on B. So the magnitudes are the same because these are action-reaction pairs. This is Newton's third law. Okay? So I could just call it F. Okay? They have 100 Newton minus F equal MA AA and F equal MB AB. Okay? Now what else do I know about this process? So I have two accelerations there, AA and AB. But the objects are, so I'm pushing one and it's touching the other, and they're moving together. So whatever their accelerations are, they are the same because they move together. Okay, so I don't need to distinguish between the acceleration of A and the acceleration of B. I could write equations as 100 Newton minus F equal MA times A, and I can write this F equal MB plus A. So these are the equations. So, I need to go. What did I do? Say it?
Move the piece of paper
You
outward.
can't see what you just wrote. Move it up.
And now?
Yeah.
Move the
Now it's fine?
Yeah.
No, keep going. Keep going. Keep going.
Oh, okay, there you go. Okay, I see what you, okay, sorry. I need to play with this.
Close.
Oh, this is- I'm sorry, I had written this and I was looking at this and this is what I wrote, okay, so I didn't realize that this part was missing. Okay. So this is what we have. Okay, so these are the final, and now I have two equations and two unknowns, so I can solve, okay? Now, so one possible way to solve these equations is to add them up. Okay, so if you add them up, what do you get? 100 Newton equal MA plus MB times A. So what is the meaning of this equation? Okay, this is just a mathematical result. Okay, we just algebra, we added up equations. Okay? But it has an interesting meaning if you look at the figure. Okay, of course I can see the figure, but you can't. Okay, so you can get used to fact that you're not seeing what I see. What this equation that just wrote means is that if you want to calculate the acceleration of the two things, you could imagine that they are just one object. And so the overall acceleration would be like calculating the acceleration of a 25 kilogram object. So that will give you the overall acceleration. So if you have a 100 Newton force and you have a 25 kilogram object, what would be the acceleration? Force divided 100 divided by 25, that gives you 4. So the acceleration of the two blocks is 4 meters per second squared. Okay? Now, this is a very intuitive result. Okay? So if you want to calculate how an object is moving overall, you just consider the entire thing to be a single object. Okay? And then, then it will be 100 the force divided by the mass of your entire object, which is 25. And here, we have actually proved that this is the case. And the crucial component of the proof is the cancellation of these two, which happens because, according to Newton's third law, these two forces are the same magnitude. Okay, so it's a consequence of Newton's third law. Okay, now, so now if we know, so now we have this 20 kilogram mass. Okay, it's moving here with an acceleration equal 4 meters per second squared. Okay? And this, the only force acting on this thing is F A on B. So F A on B is the mass times the acceleration, so this is 20 kilograms times 4 meters per second squared. This is equal to 80 newtons. Okay? And so the answer to the problem is 20 newtons, 80 newtons. Okay? And I hope this is one of the answers here. So you can do this problem mentally. Okay? So you say, well, 100 divided by 25 is 4, this is the overall acceleration. So now I know the second mass has an acceleration of 4. So the mass times acceleration has to be equal to the force acting on it. Okay, that's 80. Okay, and because that is the only force acting on it, so there has to be the force with which the light box pushes on the